you know if there's another USB-C one or just the one? All right, we are set up. Just doing a quick audio check, making sure Calgary can hear me okay. Jared, you want to be my person who helps me monitor Calgary, or is somebody else doing that from this cohort?
Monitor Calgary.
Just their Slack channel. Just for questions and stuff.
Oh, just if they have a question, let you know.
Just proxy them, yeah, like, hey, Calgary, this person from Calgary has a question. Can you check Slack? That sort of thing. Or even ask the question. You mind doing that for me? Yeah? I'll probably ask one other person in case, like, that way you're not constantly feeling pressure. I can try afterwards. I'm just running a bit behind on lecture, if that's okay. Sorry. Web ft cal. So you'll just type in web-ft-cal. It should autocomplete. Is it not? Command K. All right, great. We are getting started. Everybody here? Looks like everybody's here. Looks like everybody's in Calgary. Hello. At least when I introduced myself to Vancouver, you folks here, I said that I wouldn't have a lecture with you this week. I was mistaken. I have a lecture with you this week. Yay. So you have to put up with me for an hour and a half or 2 hours. How's everybody feeling? It's a Thursday. That means we've gotten through some of the introductions to things like objects. I know that yesterday was a little bit rocky with the morning due to emergency with Don, so you guys didn't have a lecture with him, but had a recording to watch. But hopefully everything went okay in terms of the day. It's a little bit of a tougher day than Monday and Tuesday, but hopefully people found it to be not too bad over here. How's Calgary doing? I have asked Jared to help me with Calgary questions and stuff like that. In case they have a question, they can type it in Slack, and then I can hopefully pick it up and answer it. Can anybody else also volunteer, just so that Jared's not doing it solo here from Vancouver? You could do it? But that means you'll need your computer beside you. Okay, sweet. And you're okay from that angle? You could see the TV? Surprising. So I'll talk a little bit about myself since we haven't really had the chance to do that. Before I do that, a quick joke to start things off, because I'm told a joke is a great way to start off a lecture, right? I try to make it relevant to the week that we are working on or to the day that I'm lecturing. In this case, it's fundamentals of programming, so it's not anything too specific. But here we go. How many software developers does it take to screw on a light bulb? How many software developers does it take to screw on a light bulb? None. It's a hardware problem. Just blame the hardware, folks, anytime there's a problem. Must be my Mac. Yeah, so a little bit about me. One of the co-founders, as I mentioned on day one, to folks here in Vancouver. For those of you who don't know me, my name is KV, or Kuram Virani, if you want to say the long version. I go with whatever. People butcher my name all the time. I'm used to it. It's totally okay. So yeah, one of the co-founders, as well as the people working on the curriculum for our web bootcamp and some various others. I also kind of manage what we do with our software internally, things like Compass. and kind of what the user experience and process looks like there. So that's actually something that's been homegrown as well as a learning management system. Actually, our graduates from like way back 4 or 5 years ago started Compass with my kind of lead, and then it was quite nascent at that time, but it's something that we needed based on a very custom kind of learning style. And today we have it still maintained by essentially alumni of Lighthouse. James, as you saw for the Vancouver folks, who works out of Vancouver, works with us full time and is actually a graduate from 4 years ago. So I work with him on Compass as well as various other software internally as well. My interests, I started with computers at a very young age, the age of around 10, I think, and actually started teaching people how to use computers at a young age as well. So kind of found my passion for both programming as well as teaching at a pretty young age. I thought I would go into teaching pretty late in life. I thought it would be I'll spend a whole bunch of time being kind of a dev and doing that stuff, and then maybe in my 60s or something, I would, as a retirement thing, go into teaching, because I always saw that as very kind of tough to change. Thought of myself as oh, I'll just part-time teach at a college or something like that. And then boot camps happened, and I kind of became aware of them and decided to actually work with one in Toronto where I used to live. Consulted with them in terms of building curriculum and actually teaching their first few cohorts part-time while doing my other startup stuff that I was doing on the side. And I loved it, and students really kind of enjoyed my lectures and my mentoring, and so I decided, after leaving that and a few years after, I decided to start Lighthouse Labs here in Vancouver, and that's when I moved here actually with the other founders to start it. Anyway, I'll leave that there. If you have any kind of questions or ideas, I love to nerd out about both software but also education. And as students, you bring a very different perspective, right? I can only bring so much as somebody who has been doing software development for 15 so years. It's very easy for educators to kind of lose sight of the empathy or the reality of what students have to go through, right? In terms of learning the things that we know for many years. So if you do have ideas or hey, this was good, but I wish there was some more of this, feel free to for Vancouver students, I sit right there. You can come chat with me. You can Slack me if you feel more comfortable doing that, or if I'm not there that day. And for Calgary students, same thing. Please do message me on Slack if you have anything you wanted to nerd out about or just chat about. So yesterday and today, yesterday was a pretty big focus on kind of objects, right? And getting comfortable with that stuff. Both objects and functions, we've covered them in the prep course, right? So you're why are we going into stuff we've already covered? Why are we going into stuff that we've already covered? Anyone who want to take a stab at it? Gotta practice. Gotta practice, for sure. They are very deep topics. Yeah, they're pretty much if you feel comfortable with objects and functions, part of that focal that we call it, right? You're going to be okay. That's a big part of software development. Because if we ask the question, what is software? If I ask the question, and I sometimes do this, what is software to you from a technical perspective? At an abstract level, what is software? Sometimes I hear answers well, software is designed to, ultimately it's for humans, right? We're not building software for the sake of it. We're building it for humans. Do you want to take a stab at it?
Yeah, it's everything that you can't see, but you can still use on your hardware.
Everything that you can't see, but you can still use on your hardware. Absolutely, that is a technically correct definition of software. Let me ask the question differently, though, to go in the direction that I want. What makes up software? Right? So not just what is software, what does it solve, but what makes up software? What's your name? Gary? A solution to a problem, absolutely, at a high level. Solution to a problem. Anything from Calgary yet? Ones and zeros from Peter, fundamentals. Yeah, ones and zeros. Software is ones and zeros and a solution to a problem. It's made up of ones and zeros. That's technically correct as well. Let's go a little bit. Instructions, ones and zeros, instructions, absolutely. Right? Ultimately, whatever we're writing gets converted, in the case of JavaScript, through a virtual machine into instructions, right? Into assembly code that is essentially ones and zeros that the CPU is able to run. So that's definitely correct from a like very low-level technical perspective. Here, let me throw a hint, because I see software as being made up of two major things, at least at the level at the abstract level abstraction that I'm thinking of. One of those things is behavior, right? And we touched on this a little bit. Software is behavior. The other thing is, actually, I'll just go straight into it. The other thing is data. Like if you think about what you're actually writing, it's often you're dealing with data in some way, whether it's a simple string or a number or a collection of things. And the way you're dealing with it is through behavior, is through actually like modifying that, analyzing it, filtering it, things of that nature. So functions and objects. Functions are your behavior. They allow you to operate on data, right? And then your objects and primitive types, that's your data. Is that a fair way of thinking about it? This is why there's a pretty big focus, both in the prep course as well as in week 1 and onward, on this focal concept, right? Because that is the fundamentals of software development. And instead of taking the academic route where we're looking at it from a theoretical standpoint, we're spending our time with fundamentals actually building some tiny little apps, right? In fact, some of them are actually quite real world. You guys have looked at low tide and have started working on it. Well, it's actually a clone of a very, very, very popular library called Lodash, right, as you know. Like, so instead of just taking an academic approach, we're taking a little bit more of a practical approach, right, which is pretty cool too. I forgot to talk about my lecture style. I will try and ask names. I will try and remember names, but I will struggle. It'll take me quite a few weeks to get all your names. I don't lecture every day like I used to. I like to take awkward pauses and sip my coffee or water that I have here, usually giving you time to work up the question that you want to ask or the comment that you want to make. We have a satellite cohort, so I'll repeat. If I don't repeat, please remind me to repeat the question or repeat whatever somebody's saying, both for your sake and for Calgary's sake. Sometimes I forget. I get excited when I'm talking about this stuff, and one of my faults is that I talk really fast. So feel free to slow me down. Hey, can you like repeat that, or can you slow down? I try to watch it as I'm doing lectures, but I don't think it gets away from me as a bad habit. So I do apologize in advance for talking really, really fast. And I like to focus not on, the way I see lectures is we have a lot of content in the lab piece that introduces new concepts and gets you to practice with those concepts. So what's the point of lectures? To me, the point of lectures is not to impart new concepts only. Sometimes we have to do that. It's a necessary evil, essentially, the way I see it, to introduce a new concept instead of in a reading or a video. But really, I want to spend time on the most valuable skills that I feel you ought to be working on while you're here during lecture, and obviously while you're here during lab. So what do you think those important skills that I'm going to try and focus on are that ultimately I want you to be like really good at, or at least focusing on being really good at as you're graduating our program? What's the most important? Is it learning JavaScript? Is it JavaScript syntax? I can tell you no. Problem solving at the highest level, absolutely. What's your name again?
Andy.
Andy. Andy says problem solving. Calgary, feel free to throw in answers. Think about layers, right? So if problem solving is at the highest, most abstract kind of word that we can use in any industry, any problem, any challenge, can you go a little bit more specific? Can you go more specific to tech or to writing code? Debugging. Structuring your logic. Yeah, so problem solving, sometimes you're debugging because you're stuck on something, right? And other times you're constructing. You're like, okay, I don't have a bug in front of me or an error in front of me that I need to solve, but I actually need to how do I get started? Has anybody had that challenge where they read an activity, they're like, I don't know how to start this. It's painful, right? It's painful, it's annoying, it's frustrating. You were saying, Jared?
That's like my biggest issue.
Yeah, getting started, right? And of course, getting started both at the activity level, like what do I do to get started? But also even at a small incremental level, right? So I think a big part of, if I was to use a word that's abstract, like problem solving, I would use, yes, logical thinking from Calgary, absolutely, that's one of them too. Applying that logic. I would use the word approach. That's even higher level than problem solving, isn't it? Dev approach. And you had a lecture on dev approach on day 2 a little bit, like how to kind of think logically, some of that pseudocoding, working incrementally. Those are things I just do naturally as a dev. I don't really have to try, right? But it took time to get there. It didn't just happen naturally. I had to like learn that on the job in my case, because quite frankly, it wasn't really taught very properly or formally in university, I found, for me, in my computer science degree. So really the dev approach on debugging, I think that's a huge one. Because debugging is a huge one because, especially as new learners, we're not just debugging when like we're on the job and somebody says, oh, like there's a bug in the software, can you fix this, Jared? That's not what it is. I mean, that's part of what it is. The other part is, as I'm working on any line of code, it's not probably doing what I want. Is that a fair statement? The computer is not doing what I want. Pretty much every dev everywhere, right? And so you're constantly debugging as you're learning, as you're building. So if you are doing incremental development, you're actually doing incremental debugging. And so if you can get good at debugging, which I consider myself to be a good debugger, I don't need to worry about how good I am with a specific language or framework. If I'm good with Rails or good with React, I know I can learn that stuff fast. I know that if I have a student who asks me for help on React, and I don't feel super comfortable with React, which is kind of somewhat true, I still generally am able to help them debug that without knowing the framework that well. That's pretty crazy, right? And that comes with good debugging experience and confidence. So definitely a big focus of what you ought to be thinking about is your approach. We talked about the 15-minute rule. That applies very much because if you're getting stuck for too long, then you're not debugging enough. You're not getting enough aha moments, right? So that's my approach to lecture, is very much trying to focus on approach and drilling that in versus like, let's talk about callbacks. Yeah, we'll talk about callbacks, but you'll be spending days on callbacks, right? Any questions or thoughts or objections, arguments against what I just said? The final thing I'll say before we move into point 4 here, which is functions and callbacks, is don't stress out at the end of the day or near the end of the day. For example, yesterday, if you're like, I don't fully feel comfortable with objects. How many people here, at least in Vancouver, and I'd love to see some emojis come from Calgary, feel that way about the last day or 2 or 3? I don't feel fully comfortable about what was introduced. Most of you, I see very few hands that haven't gone up. Is that a problem? No, not in my opinion, right? The reason is, while it's being introduced on that day, it's not like, oh, we'll talk about objects, and then like, see you later. We're not going to use them anymore. That's not it at all. We're actually building on these things every day. So while today is about callbacks and functions, you'll still come across objects, and definitely more so in the remainder of week 1 and 2 and so on. So these are just the introductory pieces, and you can expect to loving the emojis coming through from Calgary. Mind blown from Cassie. Amanda's putting up is that a Dawson's Creek emoji? Nice, crybaby. Yeah, so you can expect the first few weeks to be painful in that respect, where you're like, I feel like these fundamental concepts I should be comfortable with, but I'm not yet, right? There's that like level of discomfort that you will have that is normal. All right, let's actually talk about some technical stuff. So today we talk about functions. So first, I'm going to have a couple of files that multiple files that I'm going to go through. As some of them are like a little bit of a review, but they're kind of fundamentals that we need to build upon before we actually talk about callbacks. Okay, because I can just define callbacks right here, right now, and introduce them the way that they're generally introduced online in tutorials and stuff, but I don't find that being very useful for students. So let's actually build up to it from a problem perspective. That's another way of my lecture, by the way, is problem first before solution. Right? Callbacks are a solution. What's the problem? Right? So let's build towards that. First off, a little bit of review. Functions are values. What does this mean? So for example, how we declare functions even is slightly different than some other people using JavaScript. There's actually 2 major ways of declaring functions in JavaScript, if you recall from the prep course. We've decided to go with this approach, which are function expressions, where you assign a function, which is on the right side here. And single equal sign means assignment, so we're assigning the right side to the left side to a variable. And we're storing that in memory, right? What that automatically is telling me is that functions are values because they're being assigned to a variable. Would you agree? This is not obvious if you're using just the regular function syntax. Ugh, can't type today. Right? Or we could use template strings there to make that nicer. See, this is complaining that it wants a function expression, but ultimately it will still work. Yep, question?
So functions are values and objects?
Yeah, I haven't gotten to the functions or objects part. To repeat your questions, functions are values and objects? Yes, because ultimately, if it's a value, it could be an object or it could be a primitive, but in this case, it's not a primitive. We'll get to the objects part a little bit. I care less about you being comfortable with that because that's a little too nuanced and JavaScript specific. And I don't care as much about your mastery of JavaScript as I care about your mastery of fundamentals, right? So functions being values is not an uncommon thing in programming languages, right? Not every programming language does this, but the ones that consider functions to be first class in how people solve problems tend to do this, right? So here it's not obvious that a function is a value, but here it starts to become obvious, but we'll see a little bit more of it. Now, what happens if I'm just going to comment out my example one here. What happens if I run this file? What will happen if I run this file? I'm hearing multiple nothing because the function is not being called, and that is correct. We won't see any output because I'm seeing that there's a function, but there's no call to that function. If I do this, it's still not a call to a function. But is it valid JavaScript? It is. This expression is, it's pretty small. What is it doing? You want to take a stab at what it's doing? What's your name in the back? Blue shirt? No worries. Take a guess. What is this line? Yeah, ideally you have a bracket, right? And then these are parentheses that you're doing to call the function. But here I'm not calling the function. Other hands are going up, but I want to give you a fair shot if you want to take a chance at it. If I'm not calling the function, what am I doing? Yeah, it's just like pointing to the function, talking about the function. Is that what you guys were going to say? Oh, that's what Calgary, nice. Yeah, it's tough to have that. OK, pointing to the function, that's perfect. Thank you, Casey or Cassie? Casey, right? Yeah, it's pointing to the function. What am I going to see when I run this? It is returning. Yeah, it's not. Yeah, it's evaluating too. I use the word returning kind of carefully because return is a specific thing from function. But it is evaluating too what this thing is pointing to, right? What this is actually containing. Let's take a look. This is the kind of stuff I want you. When I say approach, this is what I want you to be doing. What does this do? The tutorial doesn't ask me to do that. The walkthrough in Compass doesn't talk about this. What is this? Maybe, well, how can I check what this is? How can I check the value of this? There's multiple answers here. Console log it, right? I want to see what it looks like. All right, let's try and run that. Before you run it, another approach thing. Have a hypothesis. Have an assumption. It's OK to be wrong. But don't go on autopilot where you let the computer control you and tell you how things are. Try to actually be a step ahead in terms of this is what I expect will happen. Run it to confirm. This is a good practice. I don't do it 100% of the time, but I try to do it 80 to 90% of the time. OK? Which is a lot. So tell me, what do you expect to see based on your understanding of JavaScript? Again, it's OK to be wrong. Object is a guess from Andy. I want to see other guesses. Andy's saying that because I believe it's today's reading that talks about functions as objects. Is that right? Or was it yesterday? It was today, yeah. Yep. The actual contents of the variable. So you would actually see the whole string for function and its contents. Good guess. Both good guesses. Other answers? There's got to be more options. No? That's it? The function is named greet, we think. So maybe it's going to say something like greet is a function. Something like that, you're saying?
Or like it's looking for a value.
Oh, like when you're calling the function, it needs a value? Yeah, but we're specifically not calling the function. So you're hypothesizing error. It's going to complain. Another language would. JavaScript doesn't. But you're not wrong in other languages. Yep. It might just say that it's a function, says Jared, says Calgary. Nice. Okay, well, let's try it. I'm going to zoom in a little bit for y'all. Here, it's saying you're trying to print out an object that is a function. It doesn't say object. It just says it's a function. It's called greet. Any other questions? It's just kind of left it there, right? It didn't give us the details that we were hoping for, but that is specific to the environment that we're in. Right? If I opened up DevTools, you're familiar with DevTools in Chrome? And I ran this exact same thing, it would actually do what you were saying, I think, which is show me the entire contents of the function, because it's a bit more debug friendly or developer friendly, right? Google has put in a little bit more effort into the Chrome DevTools to go further than just showing you this, right? But ultimately, it's telling us that we're pointing to a function. It has not called the function. It has not tried to execute line 9. Did not run, right? In order to run that, I would have to say greet and then pass in a value. Oh, by the way, what happens if I don't pass in a value? Quick review there. Error is a good assumption. You're saying it'll just say hello, also a good assumption. These are the things, this is what I mean by approach. Right? Try this out. It's OK to be wrong, but you'll learn something this way instead of just from tutorials. Any other guesses? Looks like print hello. Well, it won't say print, right? But it will print, oh, I see what you mean. Print hello space, just space. Undefined, says Ahmed. All good guesses. Let's try it out. Different languages will behave differently with this. And all of these answers are correct at a universal level, but some of them are not correct from a JavaScript level. Hello undefined. So in another language, it would actually be an error saying, hey, you're supposed to pass in an argument, one argument to this function. You're not. That's not kosher. In JavaScript, it's like, nah, that's cool. I'll just assume that you passed in undefined there. So it literally is the equivalent of undefined being passed in there. Right? You guys with me so far? Am I going too fast? Fast? OK? OK. So we saw it basically took the word undefined and turned it into a string of words word undefined. Yeah.
Does it actually pass in undefined, or is it just pass in nothing?
It passes in nothing, and nothing means undefined. I didn't repeat your question, but hopefully that was clear enough for Calgary as well. So yeah, nothing is being passed in. And so we could do this as well. This is valid. And it will pass in 3 undefined. And JavaScript's even more flexible than what I said earlier. It will allow this, even though this is 3 arguments. And it's supposed to only take in 1. Right? And of course, if it takes in undefined, I can pass in other values here. Totally OK. JavaScript's just like, it's cool. It's chill. Which is good and bad, depending on how you want to look at it. It's not giving you kind of, hey, this is not going to like work as you think it's going to work. But it can be leveraged in some powerful ways as well. Again, another language, that would be an error. Trying to pass in 3 arguments for 1, not an error here. The first one's still undefined, which maps to our first argument here. Right? Any questions about this or confusion or anything like that? Awkward pause. Cool. So in order to actually get this to work, the way it's intended to be used, we do something like this, and we see it come. come up, right? In terms of functions as values, though, we can go further and be like, what happens if we do this? Because we can just talk about greet without the parentheses, without calling it, right, Andy? And so what happens if I just assign it to another variable called say hello, let's say? Is that possible? Is that allowed? If it's a value, I should be able to assign it to a variable. I mean, I did it in the first line, line 8. Right? You're able to see that? Peter, right? Yep. So what happens if I do this then? I mean, I want to see what that value is, right? What do we expect to see there? Function colon say hello is Andy's guess, and your name? Chai, yes, Chai. Chai saying function colon say hello. One other guess could be function colon greet. It's going to be one of those two, most likely, if we don't think it's going to be an error. Sorry? Undefined is a guess, but it likely won't be undefined, I think, because we have a value here for greet. We can even print out we saw the printout value that it's a function. And so we should be able to assign it to a variable, right? And we know that it's not undefined here. If we did equals undefined, then yeah, you're right? Then we would see undefined there. But greet is not undefined, we know that. And so it's likely not going to be undefined, but in another language it could be an error, right? In JavaScript it's not, because functions are values. And actually, it says, yeah, that's the function greet that you had declared earlier. So we just learned something. That when you initially define a function, it gets its name from the first variable that it's assigned to. And then that variable, that name carries forward, even if you try to reassign that function. Right? Interesting. It's an interesting JavaScript-specific thing. But it may help us with our debugging a little bit later on.
What would happen if you then, after you assign greet to say hello, then you reassign greet to something else? Or you say greet?
Yeah, Andy's question is, what if you reassign greet, the variable, to something else? That's a good question. We can try it, actually. Why not? For that, const will have to be changed to a let. Do we agree? Because const won't be reassignable. So let's just change it to a let. And then Andy's point is like, OK, what happens if I just say greet is now equal to another function, right?
Or could you mean something else?
Oh, yeah, even something else, like 5. Yeah, greet is now 5. Now if I console log say hello again, right? Let's say this is the after. And let's say this is the before. Just to see kind of like what is it before it gets reassigned. Greet specifically gets reassigned. Will say hello still say that the function name is greet? Or will it say hello? There's two possible outcomes here. Either it's going to say hello or it's going to say greet. How many people think it's going to be, or it could be undefined, I guess, third option. How many people think it's going to be undefined? How many people think it's going to be greet? 1. How many people think it's going to be say hello? So really, nobody wants to participate.
5.
Oh, it could be 5 as well. Yeah? How many people think it could be 5? It's likely not. OK, 5. All right. I don't think it'll be 5, but actually, I'm not even sure myself. Let's run it. Oh, that is not what I expected.
So even the before, maybe it has to do with const?
No, it doesn't have to do with const. But let me just move this out just to be extra. Oh, so that's actually happening because I put in the string like that. So that's something where, like, if you want to see the details of the function, you can put in a string before, like a string earlier. I didn't know this. And then it will actually like give you a much more detailed version of that function. So let's just get rid of that because that's something new that we did. It's actually keeping the name greet. Because like, I guess when you assign it to a variable, it's like, OK, I guess that's the name I'm taking. And then it creates a copy for that for its name. And yes, functions are objects. I'm not going to go too much into functions or objects because it's like a rabbit hole and a little bit too far away from what we want to go towards with functions. But yeah, functions are objects, so you can access them with properties like f.name. is a property. Just like yesterday, we created our own objects using curly brackets. Functions can also be assigned properties with dot notation, or we can read their properties with dot notation. So we can see the dot name is actually a legit property on a function, and it will be the name that we see being used in the debug statements above. Pretty cool, right? But where are we going with this? So let's take things a little bit further. This is a good like review slash like, okay, I didn't really fully know this, so it's good, fundamental. Let's talk about file number 2. If functions are values, can they be passed around? Now, we already kind of passed them around, right? We took greet and we passed it to say hello. How else can we pass around data? Something like that. As a parameter for an argument. I can call f, right? What will this output? The return value of f, because f is being called, it will output 6. Agreed? But if I have another function, I'm keeping things pretty uncreative right now, just to keep us focused on the concept, and then we'll do some more creative stuff with it. So now we have another function which can potentially take in any data, but we decided that we want to pass in the function and see what happens. And we want to just, what's the simplest thing I can do? Simplest thing I can do is just console log it to see what happens as an experiment. Agreed? And so now I'm going to just call in takes in function. That's a call. And I need to pass in the previous function. How do I do that? F, not f parentheses. If I do f parentheses, what am I passing in? I'm passing in the return value that's processed and returned by f, which is 6. So here, I expect 6 to be console logged, because that's what's passed in for func. Agreed? So let's just confirm that. Indeed. And what happens when I do this? Now, based on what we already did in the previous file, you should have a pretty good educated guess. Yeah, function f is being passed into this takes in function. How's Calgary doing? Haven't heard from them recently, so just making sure they're good. And so we should see function f. Holy crap, we can pass in functions into functions. This opens up, right now it's hard to understand what the hell it opens up, but it apparently opens up a whole bunch of flexible programming and more powerful programming. Okay, and we'll start to see that for some of this lecture as well as for today. Nice. Loving the use of emojis. Nothing surprising here, but perhaps something new. So now the question is, so what? Right? Like, what's so great about this? But the other interesting takeaway also is that because functions are values or objects, they're essentially also data. But when I started off this lecture, I said software is two things. It's behavior and data. And behavior are like our functions, our programs, right? And then data is what they often operate on. And that's separate. That's your objects, your arrays, your primitive types. But actually in JavaScript, it seems like, because a function can take in a function, and a function takes in data, it seems like that line, that separation is kind of fuzzy. That code is actually also data. Because I'm not passing in a value like 5 into this function. I'm passing in code. Because a function is code that needs to be executed later. Agreed? And so in JavaScript, we're actually, in other languages like JavaScript, we're actually able to pass in that kind of behavior into behavior, which is a little bit meta and like You know, that exploding emoji icon. Okay, let's go further. Okay, so now we're going to start with the problem, not just go, okay, cool, let's talk about callbacks, but I still don't understand what the hell callbacks are and what is the actual problem, because all we've talked about is a few kind of cool things or solutions in JavaScript, but we haven't really talked about a problem yet. So let's say this is the problem. We're going to write a function to loop through each item and print out the output, like something really, really simple. We don't want to keep it too complicated, so we can go through it reasonably well, and then use it as a platform to talk about whether we can have a need for callbacks or not. So let's write that out, shall we? What's my first step? So the answer is declare a function that takes in the items, and then you can start from there, and maybe put a console log in there, and want to work incrementally, right? I would actually say, and this is something maybe new to you guys and to Calgary, that is a good answer, but not a great answer. And it's the answer that most of you I would expect to do, so I'm not surprised. Implement the function. At least start with the skeleton of the function. Right? That is how we're kind of taught by online tutorials, by even our prep course and things like that, which is good, it works. But I'm going to introduce something new. Start with an error. Start with an error. Was that talked about? Who was your lecture on Tuesday? Travis? It's not really a directive for him to talk about that, but I'm curious if he talked about errors first. Did he? No. Great. That's perfect. I'm happy about that, actually, because I'd rather you get introduced to that a little bit later, which is like around right now, and really start to think about that like the tail end of this week and early next week. What the hell? Errors? Those are the things that are like red and I'm nervous about. They make me anxious. Is that a fair statement? I bet most of you, before you run the thing that you've written to partially solve your problem, are either consciously or subconsciously a little bit nervous or anxious to hit enter on the run command because you're worried about seeing an error. Fair statement? I'm seeing a lot of nods, at least here from Vancouver. Is there a nod emoji? No, there isn't. Too bad. But yeah, I expect to see a lot of nods from Calgary as well. We are trained in terms of other professions, in terms of as adults, as humans, that errors are bad. Right? We talk about debugging. Why? We need to fix errors. Errors are bad. We see red on the screen, we have an immediate negative reaction. We felt like we did something wrong, either as users or in this case as developers. I want to change that mentality. That is not good developer mentality. Actually, I want you to flip it. I want you to actually be happy when you see an error, eventually. And I want you to actually try and wrangle or control errors to your advantage. Okay, I call it error-driven development. It's not a thing that you'll find too much on online. But it is actually a core concept that many developers do. They have a different word for it. I'm not going to throw it out there right now. But I'm going to take kind of that more conflated term and extract one of the principles that many good developers use, which is error-driven development. Write an error first. Okay, what do I mean by that? We said we need a function. I'm actually going to call a function. I don't expect the function to actually run. It's not there. What am I going to call it? Well, I need to loop through each item and print it out, so maybe print items. Is that a fair name? And I'm going to pass in items. There. And now I have an expectation of an error, and I'm going to learn about errors. It's not just about like training myself to not be nervous about them. It's also about like learning a new language or a framework by understanding its errors. Because yeah, a tutorial just tells you how to do things successfully and you do it, but that's not where you get stuck. You get stuck when there's a problem. So why not introduce the problems first as much as possible? So I would argue that this is a good way to start a Hello World tutorial or something like this. Let's try and actually call our Hello World, or in this case, print items function, and see what happens. What do you think will happen? What will be the error that you expect to see? Print items is not a function? Is not defined? Something like that? Hail ye. Yeah, let's do that. So let's call 3 and expect to see something about the function not being defined. I don't feel nervous about this error. And maybe this is the first time I've seen this. Reference error, print item. Okay, cool. Like I've seen it in other languages. I didn't know how JavaScript talks about functions not being defined. This is now something new I've potentially learned. And now I'm going to, next step in this process of error-driven development, I'm going to solve this error. How am I going to do that? Define the function. Now, I could say items here. I'm not going to. That's not good practice because it's the same name as the thing outside. So I'll call that array or something like that. You could be tempted now to write more code inside of that function, but remember, with error-driven development, we just want to write the minimal amount. Okay? So I don't need to put anything in here to solve this error. Now what do I expect to happen? What's my next error or problem? No error, and nothing will happen is correct. That is also an error, essentially, because it's not what we want. But we have a hypothesis. It's not an error being printed out to the screen, though. Awesome. Now, I'm going to go further and say, OK, well, that's my problem. I don't see anything. I'm going to solve that problem by simply logging the array. Right? And then my hypothesis is that I'm going to see the array and so on. I'm going to leave error-driven development there. I don't expect you to practice it today, but you can try it out. We'll have a more formal lecture on it come Monday, I believe. OK, so Monday of next week, because it is a thing that's more and more going to be helping you with your entire kind of career as a developer. We're at 50 after, so we're essentially 45 minutes into the lecture. We haven't fully implemented this, but what we'll do is we'll take a break. Let's say 7 minutes, and we'll resume. So what time is it right now? 50 after. We'll plan to be here at 57 after so that we can start on the hour. OK, thanks. Hey, good idea. Coffee? Yeah. How's it going for you so far? Did you get to the end of yesterday or close?
Yeah, I did finish
Nice.
this morning.
Okay. Oh, nice. Right? Like if you're like 80% done, but,
Yeah, I'm not able to do stretch projects. I'm able to
yeah, that's the important stuff for sure. And the stretch is good. Even I tell our alumni, like very few, no one actually has a stretch done by the time they graduate. So that's great, like things to go back to keep active and keep fresh, right?
I was thinking weekend.
All weekend, but some people are playing catch up on weekend. Like you don't know enough, right? Or Friday's material is also like quite different and not easy. And might be like, I didn't get that much done. I left at 6. Now I'm gonna have a weekend catching up on Friday, Thursday, that sort of thing, right? So, and then you have homework on the weekend as well.
And I'm very much excited for tomorrow's mock test.
Yeah.
because it will be first.
Yeah.
So
Yeah, the first one's jarring, so we keep it very kind of like, you can ask for help if you want, but for the next ones you can't. And then you can use it your weekend also to catch up and like not a 2-hour window. But eventually we make it a 2-hour window, and starting with next week it'll be you can ask for help. It'll be more of a real test as opposed to a mock test. Yeah. But I think it's really good practice for what's really happens for assessment in the world, right? Like it's good assessment, but it's also good practice for tech interviews.
I really love this small assessment quizzes that we're taking.
Yeah, that's good.
It actually helps me to think about the concept.
Yeah. Even the questions in the
Yeah.
sometimes it's the quizzes, but sometimes it's even the interactive questions in the activities. That's new actually. That wasn't there until like a month ago.
Oh.
Like the orange questions. Yeah, that's new. Yep. Thanks for helping with the Calgary stuff, by the way, with the messages. Is that your breakfast, Jared? Vending machine? No, you brought it from. Yeah, I had Kit Kat for breakfast, so I guess we're both pretty bad at it, eh? Never mind. I'm alone. I'm alone in my terrible breakfast habits. All right, looks like we're going to resume soon. Everybody's pretty much back here. Hopefully Calgary as well. Okay. Is everybody back here? We're waiting for. Okay. Well, we'll start anyway since we are at 59 after. So here we are. And we have our function that we defined. It's supposed to loop through the items and print them out, right? Well, right now I'm just printing out the entire array. What I need to do is actually loop through all the items, right? So how would I do that? I have many different options. I can use the traditional C-style for loop with for I equals 0, I is less than length, and all of that stuff. But unless I need some very powerful looping that's like custom, I don't really need to use that loop. I can kind of go from beginning to end fairly easily using a more modern loop, right? The for of. So let's go ahead and write that. Does that look right? And now when I run this, what I expect to see, again, try to have that hypothesis before you hit enter, even if it's not an error that you're expecting. So here I'm expecting the items to be printed out one by one instead of in an array format, and each one on a separate line, because console log adds stuff on new lines every time. Nice. Cool. So what's the actual problem here? Well, let me ask this question. What is the responsibility of print items right now? What are the things that it's responsible for? It's responsible for looping and printing. Right? It's kind of doing two things. It'd be nice if our functions could just be really good and do one thing and one thing only. Why? Well, because they can be more reusable. Right? This is one of the best practices or good practices of creating software is to write small functions that are good at doing one thing, and then other functions can leverage that one thing. So in this case, that's not so much the case because they're doing two things. But another way to look at this also is that if I have anywhere in my software, and this is fictitious, a need to print out things in an array later on, I'm constantly having to write functions that do this kind of thing. This is not very reusable. What if I wanted to loop through them and I wanted to not just print them out, but I wanted to like print them out with a little bit of a context? So in the case of items, yeah, I just want to print them out just like I am here. But in the case of some other thing, later on, maybe it's array of objects, maybe it's resumes or something like that, and I want to actually print out the name on the resume as well as various kind of details about that resume, not maybe the whole object, right? Maybe I want to like just see the important details that are important to evaluate each resume that I'm looking at to see if they're fit for the job. I'm just making stuff up, but like the idea is that I have another collection of things that I want to print out in a different way. I would have to write a print resumes function in the way that I know currently that does the looping and the printing and does both those things, right? Do we agree? So that function would be it would be again very special purpose because it would just be for resumes, because it would understand the resume object. It would understand that there's a property called name and there's a property called years of experience, and those are the things that need to be printed out inside the loop. Can we make this a little bit more generic so that we are not doing both things? Can we improve this a little bit? even with just print items, can we make it so that there's not one function that does both things, but two functions that each do a thing? And the callbacks is not the answer yet. There's a non-callback based approach that I'm expecting you'll jump to, since you're not comfortable with callbacks yet. How do I turn this one function, print items, which is doing two things, both looping and printing, into code without using callbacks or anything fancy, into code that is, well, the function's doing one thing, and then there's another function doing one thing, and together they're solving the same problem, which is to print the items. Use return? But if I use return, then if I use return in here, it's going to just stop with the first item and it's not going to keep going. Do you mean something else? Create another function because we want to split this up. What would that other function be responsible for? Yeah, that seems like a natural thing. One is looping and one is printing. So instead of print items, we'll give it a new name later once we figure out exactly what it's doing. But instead of this console log being in here, which could be something very custom, like again with the resumes example, why don't we just move that into its own function? So instead of print items, it's print item, and we pass in the item. Right? And again, I'm going to cause the error before I implement that function. So let's go ahead and run that. I expect an error. Print item is not defined. I'm going to go ahead and define that function. Right, I kind of did two steps here. I also gave it a body, which is the console log statement from before. And now what's happening is, for each time that it's looping in, it's calling this other function. How many times is print item being called? 4 times in this case. This one's being called once. Agreed? And it's responsible for calling print item. In the case that print item was like maybe a longer piece of code, this would hopefully resonate even more with you, because you would see like, oh, this function was like 20 lines of code, and now we've taken the inside of the loop and made it its own function, and now this function is only 10 lines of code, and this function is only 10 lines of code or so, right? And so there's separation happening, just it's getting cleaned up. It's not a huge function, because ideally you don't want functions to have too many lines of code. It's usually a code smell. It's doing too much, most likely, right? And this is a simple example, but you can imagine a case where the console logging was just more complicated or something of that nature, right? So we've taken a larger thing that's doing two things and broken it up into 2 different functions. Have we solved our actual problem, which is that this function here, print items, is responsible for only doing one of those things? Peter's saying, well, still doing both, in that the net result, the end result is still that we are printing the items. But it's shifted, so it's accountable for printing the items, but I would say we've shifted the responsibility. Is that a fair statement? So we're kind of halfway there. Right? Like I would still shy away from not calling this print items, because ultimately when you call this, what happens? The items get printed. And the name should reflect what actually it does, what it's accountable for. But it's delegating some of that responsibility to another function. So we're at least a bit better off, aren't we? Right, Jared? Are you guys sold on that or not really? Sold on it? So what's the negative here then? If this is a half solution towards making this print items a little bit more generic and responsible for only one thing, what's the problem that we have with splitting out into 2 functions? That's a new problem, essentially, that comes from this, specifically when looking at this function. I'll ask over there, actually, if you don't mind, Andy. Yeah, what was your name again? Grace? Go ahead. What do you mean by if something is wrong with print items? I mean, if there's a bug, there's a bug. Yes, so if the loop is kind of broken or something like that, it won't necessarily call print item properly. But that would have been a problem even with our first solution, where if there was something wrong, it wouldn't have printed the items. Are you saying something more specifically about, you're onto something, but you're looking at it slightly the opposite of what you should be? Let's look at our goal again. Our goal is to make print items more generic and more independent so that we can be reusing it for other things like resumes and so on. And we can't. And we couldn't before. And while we're closer to our solution, we have a new problem in terms of trying to make it independent and atomic and just kind of do one thing. This is a step in the right direction, but it introduces a new problem. I'm seeing puzzled looks in Vancouver. Anybody in Calgary? What's happening here, the problem, I'll give you the answer, is while this is better, one of the challenges with this is now, whenever I want to use print items, I also need to bring along print item, singular. Is that right? If I commented out print item right now, will it work? No. The opposite of what you're saying, right? If something's wrong with print item, print items is not going to work. And more importantly, not that something's wrong, it's coupled. These two functions are coupled together. This function assumes, so if I was to put documentation, this would be something I'd have to provide to the developers just so that they understand that this function expects you to define another function called print item. So please define that function because it's just going to go ahead and assume that name and call it. Right? There's a name-based coupling here. That's not ideal. If we could only solve that, we would have a more generic function. Sorry? You're onto something. What's your name? Josh is onto something, but he's articulating it in a confusing way.
Don't we still want to take print item completely out of print item function?
Ultimately, the question from Jared is like, don't we want to take print item completely out of the print items function? The truth is, you're at some point going to need something that you're calling to loop through and do something with each item. But what we want is for it to not be too specific to the task. So this particular function is responsible for looping and printing each item. Wouldn't it be nice if we could turn this into responsible for looping and, unfortunately we'll still have an and, doing whatever with each item. That's more generic. We'd be able to use it more, right? Because we constantly have to loop through things and do something with them. Yes, we use a for loop. It's not a big deal. But if we're going to use a function that does both of those things, it'd be nice if it was more generic. So as it turns out, there's something built into JavaScript that we're going to look at both as a consumer, like we're going to use it, that actually solves this for us. But hopefully we'll be able to appreciate it. So it's called for each. Let's say you have an array of things, right? We can say names.for each. You may have seen this actually in the prep course and some of the Udacity material and so on. I just say on that array, call for each. So we already have, for each already has access to the data. And then we can say, I want to pass in the behavior. I want to pass in a function. And that function will take in each item, and I'm going to console log, in this case, each item. So this function that I'm passing in into for each, remember this is getting a little bit hairy, but remember that this is our function call, this parentheses are our function call, right? We're calling for each, and we're passing in one argument, and that argument is a value because functions are values. Remember that? And that function, that value is a function that does something. So now it's not print each. JavaScript doesn't give us print each or something of that nature. It's just like you could do whatever you want with a generic for each function that takes in a function, just like we talked about early on. You can take in functions. And that allows you to decide what to do with it. And this is going to be confusing. I'm assuming this is going to raise eyebrows. It already is, actually, at least here in Vancouver. Like, what? But let's just first run this, and then I'll speak to it a little bit more. It does work. It goes through each item, and it prints it out. I can decide if I want to change the console log behavior. And I'm able to customize what my function that I care about, which is what do I want to actually do with each item. I can customize what it does. But did I change the logic behind for each? No. For each stayed the same. It's built in. And I'm actually able, and did I have to define a function called print items or print item, singular, in order for each to work? For each doesn't assume, oh yeah, you'll define a function called do or execute or print item. It doesn't care what you name it. Because JavaScript has the ability to pass in functions, why should you need to assume names? Just pass in the function that you want it to call. Right? Don't worry about names. So here I'm just going to write that. For each is similar to our print items, except it doesn't assume that we want to print. We could want to something else with each item. It doesn't expect us to define our each function, let's call it, with a name. Since in JavaScript we can just pass in functions into functions. Why bother with a name if you can just pass in the behavior? It doesn't need to reference it by name if it can just have the whole behavior. Now something else is happening here that's really bizarre. We haven't really been used to defining functions this way. This function has no name. I didn't do const x equals this thing. Yeah, remember how JavaScript works. To answer your question differently, remember how JavaScript works. Before calling for each, it needs to evaluate what to pass it. And so it's like, oh, I need to figure out what's inside of these parentheses, this thing here. So it's like, okay, I guess that's a function. It's not going to run the function, because functions don't run when you declare them. It's when you call them. And we're not calling this function anywhere. We don't need to call it. For each needs to call it. So we just let JavaScript create that function in memory. We don't assign it anywhere. We don't give it a name. Because for each also doesn't need to call it by name. And it just assigns it to one of its arguments. Its first argument is a callback function. This is what a callback function is, by the way. Is a function that I've passed in that's being called back by for each, not by me. That's all it is. Right? It has an ominous, scary sounding name, but it's just a function being called in so that it can be called later. Right? We could decide that we want to give it a name. We could be more articulate, and we could say, I want to have a function called print name that is this function. I mean, I've taken the right-hand side, and I pasted it there, and that's my valid JavaScript syntax that's allowing me to define print name. What would I do in that case? Print name in here. That would work just the same. To JavaScript, this is equivalent. In our head, if it's easier, you can write code this way, or you can visualize code this way. But we can make this a shortcut and just put that right side right into the parentheses like we did earlier. Both are the same. In this case, though, I have an advantage in that in case I wanted to use print name 3 times, might as well give it a name and pass it 3 times instead of declaring it 3 times. So sometimes in code, you'll come across functions that are passed in, but they're given a name first because we want to use them multiple times. But if I don't need to use them multiple times, I don't need to give it a name. Yeah.
The audio went out at 11:17 temporarily. I'm not sure if they missed anything.
Oh, I'll just repeat myself because mostly I am already repeating myself. Hopefully it's back though, right? Is it okay so far? I wonder why that happened. Is it okay now, hopefully? Okay, great, thank you. Yeah, so basically what I was saying is we've defined now a named function, just like we had before with say hello or greet, and we're just passing it in. That's passing in a callback function. We can choose if we want it to be anonymous or not. So here, not anonymous. I am not going to do this though, by the way. I'm not going to call it. That's not the goal. If I call it, I'm calling it with undefined. We saw that earlier. I need to pass in the function into for each, which will call the function for us multiple times for each item. So let's just run this to make sure this is working. And indeed it is, right? And then the other way I can do it is just pass in an anonymous function that defines its behavior right then and there before it's passed in. Same idea. But we don't need to give it a name since we're only using it once. And now we're going to see both of them do their thing. We're calling for each twice, so we're looping twice. How are you guys doing? Is this confusing or weird? What have we accomplished is the thing. Well, our problem was we didn't have a generic function that could loop through and just do whatever. And when we did try to go towards that route, we created another function which was better, but we had to know its name, and then our print items had to call it by name. Right there. Instead, what we can do is make it even more generic, and that's already built in, like for each, which just takes in a function to execute instead of having to know its name. This part is usually the most confusing part of this lecture. So I'm going to pause a little bit, let people work up the courage or whatever it is that they need to ask questions, or just say, I don't understand. Can you explain this again? Let me actually split the screen a little bit. Which one do you want me to go back to? Okay. No, not that one. The for each one, yeah, sorry. That's 4, right?
I have a question about for each.
Yeah. Who was it, Andy?
Yes. So how do you know that for each is going to pass something down?
That's a good question. I didn't address that. So the question from Andy, for everybody here and for Calgary is, how did you know to pass in a function that takes in an argument called item? Let's actually open up the documentation for each, which is the step I skipped conveniently. I switched over to Firefox recently. I'm leaving behind Chrome. I haven't fully transitioned yet, so this might be a little bit interesting, but so far it's okay. So according to MDN, you can run it on an array. And it executes a provided function once for each array element. That's a pretty simple explanation. Here's an example. It's pretty much what we did. And here they decided to call it element. When I define a function, I can decide whatever I want to call its arguments. But we have to know that it takes in an argument. How do we know that? Documentation. Take a look at what it's saying. When you call for each, you pass in a callback. How many arguments is the callback taking? Actually, the callback is right up until here. Anywhere from 1 to 2 to 3. With JavaScript being flexible, they're just like putting them in square brackets, not to indicate that they're arrays, but that they're optional. So that means I can actually, for the second argument, I can look at the index. Interesting. Let's call that, in our case, let's call that I. So I'm now putting instructor followed by whatever this index is, followed by name, which is followed by item, which I could decide to call name. Doesn't matter as long as it's the first argument. And we can see that we can get access to that. So because remember in the very first exercise that I did, JavaScript doesn't care if you accept all the arguments, if you pass in all the arguments. We can choose to ignore the second and third, which I did. And now I'm not ignoring the second. I'm actually using it because I need it. Yeah, I've decided. As I'm looping through, I want to know which position I'm also dealing with. The next thing I'm going to do, because this is still like, I don't understand what's actually happening underneath here, is my guess. Like people are like, what's actually happening with for each? How does it work? What we're going to do is we're going to actually implement our own for each next. And we'll just, because for each, we already have it, we'll just do for each backward, because that doesn't exist. So we'll just implement for each, but just go backward. Is that OK? So let's do that. So for file number 5, let's implement our own for each. Let's call it for each backward, because for each already exists. How would I go ahead and do that? So first, let's actually implement this in the way that we know already, and then we'll refactor it to use callbacks and be the way that we expect for each to work. Is that OK? So I would call the function for each backward, which for now is just going to do both. It's going to print each backward. It's going to for and print, just like our previous one, which was doing 2 things. And then we're going to get to doing it 1 thing. So print each backward will take in the data. It needs to take in the data because we're not doing data dot. Okay, so that's a slight difference from for each. Because with for each, we call it on the data. Here, we're not calling it on the data, so I'm passing in the data. Okay, just so that that's clear. And that should go ahead and actually work. Of course, for now, it's going to be an error. Right? Can't find that function. I'm going to go ahead and define that function. It's going to take in items. And it should, of course, loop through those items backward. But until then, I just want to make sure I haven't made a mistake. And in typical incremental fashion, I'm going to make sure I do step by step. OK, so I've got my array. Now, I need to loop backward. I can't use for of to loop backward. For of just goes from beginning to end. I could use for each, but for each also does the same thing. It goes from beginning to end. How can I go backward? Yeah, I could use a while loop, or I could use a C-style for loop. So I'll do that. It's not going to start at 0. It's actually going to start at items.length -1. Start at the end. I'm going to keep going while I is greater than or equal to 0, because I want to go all the way to 0. This is my while condition. And I want to keep going down 1 step, so that's I minus minus, or I minus equals 1. We'll just leave it like this. Okay. And then in here, for now, I'm just going to console log I, because I want to see that it starts from, what should it start from? So that should be, what's the first value? 2, 1, 0. I'm just console logging I, not the item in the array. Let's run that. OK, so far so good. I have a good handle on that. Now I'm going to need the item. So that's items at I, using similar to object notation, but in this case, array notation, square brackets with the index. And then I'll just console log the item. Right? I haven't really solved the problem of creating a generic for each backward, but I've implemented a part of the solution here. And what we had done last time is we had said, oh, that should be its own function, because console log, we don't know if we want to console log. We don't want this function to be responsible for both. Let the other function decide what should be done. Should it be console log? Should it be a fancier console log? Those kind of things. So we're not going to do that here. We're just going to call print item. Right? We're not even going to call it print item, because we don't know if it's printing or doing something else. So we'll just call it do whatever. And this should work the same, because all I've done is moved that one line into its own function and then called that function with the same data. Right? Same thing we did before with our print items, where we implemented a function here that took in the item. Right? We have done pretty much the exact same pattern, except backward. Agreed? So we're continuing where we left off, except we're going backward. This should work. I should have done this in an error-driven way, but I forgot. Still continues to work. And just to confirm that I'm actually editing the file, I always like to, I don't trust myself, so I just want to make sure. Yeah, there we go. So this is working as expected, like before. Any questions so far? We're not done yet. Any questions? It has the same problem, right? It needs to know the name of the other function. So what do we need to do next? Based on what we learned from for each, what do we need to do next? We don't want to hard code the name here. Yeah, we want to take in a function. We've already done that very early on with function passing, where we passed in this f that returned 6, and we could call it if we wanted to. So we'll do the same thing here. We'll take in a second argument called do whatever. We could probably come up with a better name, but I'm being dramatic with it, right? And then that's our do whatever. Now it's a local name. It's not called that globally. And this now can just be called print item, because that's what it does. It's more specific to what it's actually doing. And when I call print each backward, how many arguments do I pass in? 2, because I pass in the data followed by the behavior, the callback function, right? I'm going to pass in print item as the second argument. Now, I would argue that this function name isn't actually representative of what it's doing. It is representative of what's happening right now, where we're printing each backward. But we could have decided not to print, but to do something else with that data. And so this function doesn't actually know if it's printing or doing something else. Do we agree? Because it's do, yeah, it's do whatever backward, which we could call for each backward as a different synonym of do whatever backward. And if we run that, hopefully that works, which is awesome. And here we can decide we want to do something different. Right? Yeah.
What was that command you used to copy the whole version and then replace it?
I didn't use a command, actually. I just double-clicked on it. But if you did want to replace multiple things in a file, for example, if I decided to rename this function, I could kind of do it one at a time, but if I use Command D, at least in Mac, on like PC computers, it'd be Control D, I guess, right? I would do that 3 times, and then I would type in do whatever backward, and then escape, because otherwise I'm going to have 3 cursors, and it gets really confusing. I'll show you that. If I do this, and then I leave it, I'm just like moving 3 cursors around, which is really bizarre. One at a time, so I can actually control how many I want to edit, because I might not want to edit it the 4th time, right? I use it not a lot, to be honest, and I care less about you mastering that right now. And you'll end up becoming lazier and lazier in a good way as a dev, and you're like, why am I having to, I don't want to use my mouse as much, right? And then hopefully you do that more. But for now, we're focused on the logic and problem solving side. But fair question. Let's not take away from this particular thing that's really important, right? What I did here was I created a generic function that takes in a callback along with the data and is now able to do whatever. And I can just take this function and use it in any piece of code that I want. It is not dependent on anything else. Do we agree? It's not dependent on another function with a given name. It just takes that function in as a second argument. Nothing from Calgary yet. Crickets. Is there a crickets thing? Nice. Crickets. But maybe that means that they're feeling all right about it. And if not, they should hopefully send me a message. Since I am passing in a callback function, I don't have to give it a name. So the other way I can do this is function item, right? And just define that function inline here. And of course, because it's a function, I'm going to indent in here. And maybe in this case, I don't want to console log them. I actually want to store them in an array. I can do that now. My callback doesn't have to be printing focused. It could be whatever I want. So now I have a reverse version of my array by using do whatever backward. Because whatever that I'm doing is actually just collecting it into another array. Do you see that? So now, roll Lighthouse hello. Got my reverse array. Right? How are we feeling about this? Confusing? A little confused? Are you confused about the why, or the what's happening, or something else? This takes some time. I'm not surprised. I have certain strategies to help alleviate confusion, but I'm not using them yet. I want to see if people can actually ask a question or two before I employ some new strategies. About the how? Okay, that's good. How many people here are confused about the how this is working? 1, I know 2, 3. So that means there's probably more that are just not raising their hands because they're somewhat confused, they're not fully confused. I want to whiteboard this a little bit maybe. Or maybe I'll do another tactic. Let me try a different approach to just kind of talk about the how this is working. Let's first reduce this code. We've got too much going on here. We'll get rid of the reverse stuff for now. And we've got our print item that's being called and is defined here. And I'm just going to document this a little bit. Print item is being passed in as a callback function. Do whatever backward is responsible for calling this function each time for every item in data. in our lecture in Tuesday, sometimes we do it, sometimes we don't. Was Python Tutor or JavaScript Tutor introduced? That's a good tool to kind of see what's happening here. Let's use it. It's actually part of Python Tutor, supports JavaScript, right? I'm going to paste that in here. And we're going to walk through it. So on the first line, we've got our data. So let's move forward. And we see that we have that defined as an array in the global context. Move forward. Next, it encounters this function, do whatever backward. And it's like, cool, that's a function. But actually, before that, it's like it ran line 3, which is print item. Sorry, I skipped that. And it's like, cool, that's a function. And there it is. Right? That's our print item function. Next, do whatever backward is encountered, but not run yet. So it will skip lines 8 to 12. But it will have registered that as a function as well. So now we have two functions, do whatever backward and print item. Our final line of code will actually invoke the do whatever backward, passing in the array as well as the other function. So where do you think it'll go to when I hit next? Because that's the last line in the file, line 16. Which function am I calling? I'm not calling print item here. I'm calling do whatever backward. And so that's the function that it's going to go inside. Because it's like, that's the one you've called. Print item has just been referenced. So it's going to take that from memory and pass that in. But it doesn't need to call it yet because it hasn't been called yet. Do whatever backward is being called right now. So when I go to next or forward, I expect to be at line 8. Because that's the function that's being called. Boom. I'm at line 8, and I'm no longer in the global context. Now I'm inside the context of do whatever backward. The next frame in the stack, so to speak. Right? And look at what's being passed in. Items, which points to that same array, data. Do whatever, which points to that same function that we defined called print item. Say that again? Yeah, print item. Yeah, but I'm passing in print item here at line 18, and then I don't refer to it as print item in here. I call it, this is an important takeaway. It's no longer called, in this context, I could use the word print item. I have access to it, but it's bad practice because then I'm coupling this function with that function. By not calling it by its actual name and calling it by a temporary name, I've decided that I can use this function anywhere, and as long as I pass in the callback, it doesn't matter what it's called actually. So in this context, it does have access to print item as a name because of how scoping works in JavaScript, but it's not going to use that name. It's going to use its own internal local name called do whatever, which is the second argument, right? Passed in through print item. And as it's now going to loop forward, we see that I starts at 2. We turn item to be world. It'd be nice if it said item here, but I think it's a little bit confused because of const or something. I'm not sure. It's a block level variable. And then, now that it's world, it's going to call do whatever, right? Where does do whatever take it? Line 4, print item. Now for that particular value, world is being passed into do whatever, which is really print item. And so we expect it to jump to line 4, which will then console log, which we'll see up above. Once it's done with that, this function, what does it return? Print item, what is it returning? Undefined. When a function doesn't return anything, it by default returns undefined, and we don't care because we don't care about what it returns, because we're not assigning that to a value anywhere. So we're like, cool, that's done. On to the next part of the loop, because we just finished right here at line 10. So now we're back to what was line 10, and because we're back to the end of line 10, we're back to the beginning of the loop to see if we have more looping to do. And then the same process will happen now for the next word, which is I equals 1, which is Lighthouse, which will then call it with Lighthouse, which will then loop print out Lighthouse. And then one more time for the value 0, which will call that. And then now we're done with the loop. The return value of this function is also undefined because it's not returning anything, and we're at the end of the line, or the end of the function. Did that help a little bit in terms of visualizing the control flow? Couple of things before we adjourn. Actually, more than a couple. There's many built-in functions in JavaScript that help us work with data. This one is called for each that we saw earlier. That helps us loop through data and call another function against each item, which we implemented backward. That's one example of a function that takes in callbacks. There's others that you may have come across actually in the prep course, now that you start to think about it. Can you think of those? They work on arrays often. So there's for each, which loops through arrays. Can anybody think of others? Push doesn't take in a function. Push just takes in what you want to add to an array. Functions that take in functions. I'll show you another one. Slice does not. No, I don't think slice is. But let's take a look at JavaScript array map. Or actually, filter is an easier one to start with. What if you wanted a generic function that could just take an array and also some behavior on how to filter it down? I have a bunch of resumes. I want to only look at resumes that are from Vancouver and have at least 2 years of JavaScript experience. Boom, I've got some criteria. That's going to be my behavior that I'm going to pass in, and then my resumes I'm going to pass in. In this case, the example is you have a bunch of words. I want to filter for words that are greater than 6 in length. And so you get back a result that is a shorter array, a subset of the data. So filter is a very common thing that we do in software. Why not make it a generic function so that we're not constantly writing that loop that's going through each item and adding it to a new array based on some criteria? Why don't we just make that generic? Built in. Right. That's my other thing that I wanted to mention before adjourning, is the syntax difference that Andy is asking about on line 3, where we see it using this arrow function, as it's called, in ES6. Okay, so we'll start getting comfortable with arrow functions today, but you do not have to use them. They're just good, shorter syntax that people write for small functions that are often callback functions. That's where they're used the most, is callback functions. So they're often introduced at the same time, even though they're completely different things. As you saw, I didn't use any arrow functions, but I could. I could change this to be an arrow function. And all I did was remove the keyword function and replace it with an arrow after the parentheses, after the argument list, remove the prefix function, add the postfix arrow, and I've got myself an arrow function. And doesn't that look nicer? Arguably. One is a lot more descriptive, the other one's, you got to kind of be comfortable with the syntax a little bit. But there are different kind of philosophies on whether this is standard practice or not. Different teams will say, no, like Don't use arrow functions, and most will say, yeah, use arrow functions, but only in these cases. Don't use it everywhere. So for example, here, many people would say leave it as is, although you could use arrow functions here as well. But they would say leave that as is, and that's what we would say to you. Leave that as is, and if you want, if you're defining a function inline as an anonymous function without a name, then use a callback, then use an arrow function, if you want. Until you're comfortable, don't worry about it. Today we're introducing it. If that's too much, no big deal. But I'm going to leave it in my notes so that you have it as an example. Arrow functions are a bit different than other functions. They're actually a bit different behaviorally, but I'm not going to get into that right now. It has to do with the use of this, which is that special keyword that you may have come across at the end of yesterday with the music library. But if you haven't, that's okay. It's a little bit more advanced. We can leave that for later. I believe you have a reading on that today, when arrow functions are introduced. Can we just do a recap of everything that we kind of took away here before we adjourn? That way it's not like, oh, we just end the lecture and it's like, what's next, right? Or what was all that for? So let's write that stuff out a little bit. What are the takeaways that we have? And I want you to help me write the takeaways. Starting from the beginning, what are the key takeaways that we started with all the way to right now? Let's start with the basics.
We learned about callbacks and
We didn't go straight into callbacks right away though. We talked about just functions first. Right? What did we say? Functions are values. Right? They can be assigned to variables, const x equals function. Right? They can be passed around. Into other variables, into other functions. What other takeaways do we have?
they should be doing like one job.
Good call. Good functions should be written to be as small and focused as possible, doing one job and one job well. Example, print item. It's an example of a good function. Just does one thing and one thing well. Right? What else? As a side note, we also learned that functions in JavaScript can ignore values. We don't need to call them with the exact number of arguments that are being accepted. So it could pretend to take in 3, but you could call it with 1, and the rest of the other 2 will be undefined. Or it could only take in 1, and you're passing in 3, and it will just ignore the other 2. It's very flexible. Most languages don't like this, but JS is like shrug. I failed to do that, whatever. Whatever. Yeah? Yeah. So since we can pass functions into functions, we learned that this could be used to create more powerful generic, let's call them generic functions, that can help us do cool things with data, like arrays in this case. For example, we saw array dot, I'll do it like this, array dot for each, We saw array.filter. There's also .map. There's many others. Okay? And these are all examples of functions that, in this case, are operating on arrays. Objects has its fair share. And you'll be implementing some, which is pretty cool. And these are examples of functions that actually are generic, right? They don't say print each. They don't say filter by years of experience, because that's too specific. That wouldn't make sense for most problems. So they just do the filter part, which is like looping through and collecting the items that you care about. But then you decide what to put in, when to put in an item into that new array so that you have a subset of the filtered items, right? So let's take a quick look at filter actually before we adjourn. You know, here's an example of an array with numbers. If I want to filter this to only have odd numbers, yeah, I could just loop through and do that. But like, let's do it the way that we could do with the filter. It would be something like this. Sorry? Not divisible by 2. So I'm going to filter. And I know filter will take in a callback function. It doesn't need to take in the data because it's on the data itself, like nums.filter. And I could use arrow functions to make this even more elegant. I'll write it both ways, actually. So here's each number. And I want to return true if the number is not divisible by 2. So that's going to return 0 or non-zero, right? Not divisible by 2. Now this is extremely shorthand, as we saw in the MDN documentation. I'm not even using the keyword return here, which is kind of crazy. So I'll untangle this a little bit, right? Yeah, you could, but then it's more clever than it is readable. Yeah. So I actually like to strike a balance between fewer number of characters is not necessarily better code, and actually readable and maintainable without too much cognitive load, right? There is a difference between clever and done well, right? But let's make this a little bit more verbose to understand what's happening. First, let's just see if it's working. Const odds equals this, so this is going to return an array, and we're just going to console log the array. Let's make sure that works. Sweet, all right? Let's rewrite this using filter still, but using the approach that we know, which is function takes in an argument, curly brackets, and we're going to return true or false based on this expression. If you wanted to be really verbose, you would say something like, if it's equal to 0, return, I don't want to filter this. I don't want to include this, so that's a false. This is the most verbose, I guess, way of using filter for this problem, which is like very explicit. If it's divisible by 2, I don't want it. No. If it is divisible by 2, sorry, if it's not divisible by 2, this is my else, then I want it. So basically the way filter works is it takes in a function that hopefully returns truthy or falsy, and based on that it will decide if it takes that item into the array or not. The filter method creates a new array with elements that pass the test implemented by the provided function. Pass the test, meaning it's a generic way of saying that you're saying true for those things. Callback. You see the word predicate, by the way. Predicate is another word for callback. Okay? That's how you can think about it. So I'll write that down as well. Predicate and delegate. Makes sense, right? You delegate to another function, or you let the other function call it back. So callback and delegate makes sense. And predicate is another term. It's a bit more, I guess, academic or mathy. And it's saying, yeah, this function, to test each item of the array, it returns, please return true to keep the element or false otherwise. I left one other thing to the very end. We're at 11:59, and I like to keep like terms to the end instead of defining the term first. These types of functions that take in callbacks, whatever you want to call them, predicates, delegates, these types of functions also have a name. Because they operate on functions, they're called something. Does anybody know? Because some people have gone ahead and done some of the work from today. Yep, that's right. They're called higher order functions. So that's a very scary name. So I don't like to start the lecture with that. It's like higher order. How am I going to understand? This is higher order thinking. All it really means is that the functions can operate on other functions by either accepting those functions or even returning those functions. We don't deal with returning functions right now. That's a bit more advanced. But accepting functions, right? Like filter and for each. These are higher order functions because they take in another function. Oh, we forgot to write down anonymous functions. We can decide to just create and pass in a function directly into another without assigning it to a variable, therefore giving it no name. That's just a, a nice to have, really. I don't really need that, but it makes my code a little bit cleaner that I don't have to assign the thing to a variable first. Unless I want to, because I want to use it many times. I like to also say, want to write down arrow functions. Great addition to ES6, and mostly used and thoroughly used by the community to express inline anonymous functions. Right? These functions that we are just passing into filter inline, we haven't declared it beforehand, and therefore they're anonymous. Arrow functions are a great way to elegantly describe that. In fact, another behavior that was kind of implied but not really shown here is that if you define them this way without the curly brackets, it's implied that it does a return. You don't even have to say return. Here I have to say return if I'm using curly brackets, but if I don't use curly brackets, for more elegance, they've decided to make, okay, if you're not providing curly brackets, it's going to return the one line that you have there. This is a little confusing, but also powerful. Mainly because of just expressiveness. It's simple if you want a one-liner filter. Very, very easy. You don't have to use the word return. It reads okay too. But don't worry about that. Don't let it throw you off. Feel free to think about it like this if you want. Okay? Oh. We'll see both of these working. I forgot to demonstrate. Any questions? We're at a couple minutes past. Any questions? I'm sure you have lots of questions. But hopefully this at least gave you an introduction. I don't expect you, just like I said at the beginning of the lecture, to now have this knowledge and be able to just go run with this. I expect you to have some context and then understand how to start learning this stuff today. Okay? I'll send out the notes, and good luck with the rest of the day. Have fun. Cheers.